The next, we are going to hear about eCard, and the speaker is Ayaka Koshibe. So she is a developer at Open Networking Lab. She is an amazing developer. So she doesn't typically stand up and give talks, so be nice to her. But she's an amazing developer, and I think I hope she's going to do a great talk as well. So, Ayaka.
Thank you, Guru. So I want to give a quick overview of enterprise cord. Oh, is this?
Do I get the right presentation for you?
Okay, I think it's on now. Okay, great. Yes, it is. So I work on eCord alongside Mark. I'm in front of everyone here because Mark couldn't make it. So hopefully I can convey everything that I need to. So I want to give a quick overview of eCord, what it is, what have we done so far, and what we have in plan. So I want to start off with sort of the motivation of eCord. So there's two key players here, the service provider and the enterprise customer. And the service provider, like to them, the enterprise is a very important customer base, but the current state of the art makes it very difficult for them to meet their customers' needs. So for example, if a customer were to request like a connectivity, like a point-to-point like an E-line, or a point-to-multi-point like a layer 3 VPN, setting that up might take days, if not weeks or months, because it takes the collaboration between many different organizations or groups or administrative bodies. Part of it is made more difficult because there's a lot of different devices. It's a very heterogeneous environment, and administration gets complicated and very error prone. And worse, once something goes wrong, the customer has a very difficult time seeing into their service that they requested, and for the service provider, it gets quite difficult to debug everything. And on top of it all, it's very difficult for service providers to spin up DNFs. So enterprises end up going to over-the-top, cloud providers for their services, and that's a source of revenue that service providers are sort of losing out on. So that's kind of where eCord comes in. eCord tries to bring the benefits of Cord to a multi-site setting for enterprises. So in specific, it enables operators to provide virtual networks on demand, value-added services on top of those virtual networks, and to be able to monitor and configure them as if they were the enterprise's own infrastructure. So in fact, we had demonstrated these capabilities at the POC in March. So what we had was a customer portal, and from there, a customer might be able to, with a few clicks, set up connectivity and E-line between their branch offices. And once that was set up, they can take a look at the connection. If they need to, they can spin up services, they can tweak that connection. So what we basically demonstrated was those three key value proposals. So now I kind of want to go over the design and implementation of eCord as it was demoed during March. So under the hood, we have multiple central offices connected together by a metro core or a transport network. I'm going to probably use those terms interchangeably. So each central office is our familiar Cord site, and each of the Cord sites are currently only have knowledge of their own central offices. So in order to let them coordinate and to create these end-to-end services connectivity, we introduced this metro service orchestrator. And this service orchestrator has a view into the transport network, plus is aware of all the Cord sites that are involved. So now if a customer was to request a virtual network, like a bundle of connectivity plus some value-added services, so we can have, again, E-lines or point-to-multipoint E-LAN. What the Metro Service Orchestrator does is take this request, determine the endpoints involved, so which sites are involved in this, this virtual network, where it needs to place down these services, and delegate those tasks, so setting up connectivity within the fabric, spinning up services, configuring them to each of the Cord sites involved. It itself will also configure the transport network so that the sites are interconnected, and it also make sure that translation happens in the edge of the central offices so that connectivity is logically maintained. And I guess another thing that I should mention here is because the Metro Service Orchestrator delegates these tasks down, it doesn't need to know about the details of the central offices. So the cord sites can advertise themselves as a just one giant virtual switch. So the Metro Orchestrator would see the transport network plus these switches at the edges. If we look at the logical organization of eCord, this is starting to look very familiar. It also has a notion of a service graph. So in our case, you might have a endpoint to a multi-site service like a carrier Ethernet application or the VNFs that are running on top of this piece of connectivity, in addition to the standard cord elements. Looking at the central office side of things, this also very looks familiar. So we would have ONOS with the various apps for SDN control of the leaf spine fabric and any of the overlays that are kind of placed on top of it. We also have the OpenStack component for service virtualization and XOS for lifecycle orchestration and like service composition. So what eCord adds on top of this is two things. The first one is a channel northbound to the Metro Orchestrator so that it can advertise itself as a big virtual switch and also receive the delegated tasks and configurations. Another thing that it has is, again, these the applications like carrier Ethernet that form the endpoint of a multi-site application. We might also have enterprise-specific applications in there as well. And the last major component is the transport control. And the transport network is a collection of possibly ROADMs, possibly packet switches. They may or may not be SDN, but they are directly controlled by the Metro Orchestrator ONOS. And because it's not just, say, a clean open flow network, ONOS would have to use its southbound pluggable driver system to support these different kinds of devices. So now if a connectivity request comes in, the Metro Orchestrator takes this request and converts it into policies and feeds it into ONOS through its northbound API. In our case, this was the MEF SCA API. That configuration is then passed on to enterprise connectivity applications that would use the information to set up a path through the transport network. But in order to do that, it also needs information from, say, path management applications like the Converged Packet Optical app in order to get this information. So that's kind of the proof of concept implementation. So now I want to move on to what we've been doing since then. One of our key partners is the MEF. So we've been working with them, even since the POC. What we demonstrated was the E-line service model. Now we've also participated in things like the LSO Euro 16 hackathon. We've also seen that for the OpenCS data center use case, eCord is considered one of the reference implementations. And there's also MEFnet, and this is a hosting environment for OpenLSO and OpenCS implementations. And since eCord is a OpenCS implementation, we hope to have it be one of the resident systems there. And the work with MEF is sort of kind of part of our current work on refining our L2 VPN implementation that we have right now. So that also includes thinking about LSO Presto as the northbound interface, not just the SCA API. We also want to start thinking about offering different types of connectivity, not just L2. So we were starting to look at L3 VPNs with one of our collaborators. And finally, because the POC was a demo, there were some gaps that we're starting to fill right now. So one of our main focuses right now is the metro level XOS for delegating the tasks to the various sites. So that's kind of like the beginning first steps in our roadmap. So again, we have L2 VPN, which we were trying to refine, L3 VPN, which we were starting to look at, and we would also like to start looking at SD-WAN type of overlays. And we might possibly have other types as well. We also want to start offering more value-added services as part of the service portfolio. And we also want better ability to monitor and control the eCord components. So we are thinking about A-Cord and how to integrate with it. And then we also want to enable as many field trials as possible because the more tested it is, the better. And we are starting to work with China Unicom, as it was alluded to in one of the keynotes. So we are doing that for now. There will be more details about the roadmap in the eCord breakout session later. So if you are interested, please do stop by and give us your feedback. So in summary, eCord is a system that tries to enable service providers to offer enterprise customers virtual networks and services on demand and give them the ability to observe and control these requested services as if it was their own infrastructure. And we're collaborating with the MEF. We want to continue to do so and hopefully have the MEF community also continue using eCord or working on it as part of their implementation. And we are planning to do more field trials, not just in 2016, but beyond. And again, another shameless plug, I guess. Please do stop by our breakout session so that you can help us shape eCord in the future. Thank you.
Very good. First of all, do you agree that Ayaka did a great job?
Oh, gosh.
Okay, any questions?